Okay, so in this video we're going to talk about simplifying expressions. And so first we need to start off with is what is an expression? So we got to remember from previously that an expression is terms that are being added and subtracted from each other. Remember, terms are variables and numbers that are composed of products between those things. So to start off, we need to remember we need to understand though what are like terms and what are unlike terms. So let's start with a like term. So a like term here that we can have is 3a plus 7a. So what you need to look for when you're talking about like terms is you need to make sure they have the same variable and they have the same exponent. Okay? Those are the two things that you need: the same variable and the same exponent, or same variables and the same exponent. The numbers, the coefficients out in front don't matter. It just matters about the variable and the exponent. Okay? So another example here of a like term for this one could be like negative 3a squared minus 8a squared. Okay? They both have an exponent of 2 and they both have just an a. All right? So an example of an unlike term in this case would be something like, let's start with one like 3y squared minus 4y. Okay? Remember, the coefficients don't matter in this case. But in this case, though, they both have a y, but the first one here has a y squared, and the second one has a y to the first power. Those aren't the same exponents, so those are unlike terms. Okay? Another example of an unlike term would be like 12y minus 6x. Okay? This one, remember the coefficients don't matter, but this one, the first term has a y. The second term that has the negative 6 as the coefficient has a variable as an x. They're not the same. So a few other examples here of like terms that we can go for is maybe just we have constants. So like negative 8 plus 4. They're both constants, okay, negative 8 and a positive 4, so they can be combined. Those are like terms. An unlike term in something that has a constant would be like if you had 8a minus 6. Well, the first one has an a, the first term has an a, but the second one has no variable, so they cannot be combined together. And let's see here, I got one more example here. We should be looking at different letters. Remember, the letters don't matter that they line up with, but we could also have one like this. 3xy plus 10xy. In this case, they both have an xy, and each x has an exponent of 1, and each y has an exponent of 1, so those are like terms. An example of something similar that would be unlike terms would be like if you had 3x squared y minus 7xy squared. Okay, the x is squared in the first one, but the x is not squared in the second one. So those are unlike terms right away off the bat. Remember, the coefficients don't affect those at all there. And also the y's are not the same exponent as well. So let's do an example. I'm going to have you try some examples here. Okay, let's start with example number 1. And I'm going to write it up here on the screen. I got 3x plus 7y plus 4y minus 2x. So what I want you to do is I want you to get a piece of paper out, and I want you to, for this example, is to write the like terms. Figure out which terms can combine together. Which ones are the like terms here. So I want you to pause the video and try and figure out which ones are like terms. Okay, so now we're looking for like terms. So I'm going to go ahead and underline them here. So in example number 1, I see I got a 3x, so I'm going to underline that with green. The one that is a like term with a 3x is the negative 2x. You need to make sure the negative 2 goes with the x. So those two are like terms. Then the second term I see is a positive 7y. So I'm looking for everything with just a y in there. And I see I got a positive 4y after that. So that one is a like term as well. But they're not like terms of the x's because those just have a y. Okay. So let's do another example. So here's example number 2. I want you to try. And we have 10y squared plus 6y minus 8 plus 12y squared minus 4. So I want you to do the same thing as I want you to figure out which terms are like terms, and then you can do something like I did. You can group them, or you can underline them or shape them, or however. Okay, so now here, figuring out these like terms, I always like to start from left to right. So I'm going to start with the y squared. I see I have a term with a y squared, and I'm going to underline it with the red. So I'm going to go through here. I'm going to look at every term to see which ones just have a y squared. So a positive 6y, that does not have a y squared. That just has a single y, so that's not going to go with it. A negative 8, that's not going to go with it. There's no variable with that one. Then I see a plus 12y squared. So yes, that one will go with it. It has the same variable. Okay, then I see a minus 4. That one will not. So then I'm going to go to my next one. So I had found all the ones that my y squared together. I'm going to go to the 6y. I'm going to underline it with a blue here. I'm going to go through. I'm going to look for every one with a y. And it has to be a single y. Well, I already know the y squareds and the red ones won't go with it. So I'm going to look negative 8. Nope. Negative 4. Nope. There's no y there. So the 6y is not going to have any like terms in this one. Okay, then I'm going to go to my last one, my negative 8 here. I'm going to underline it green. That's a constant. Remember, just a number with a positive or negative number that's being added is called a constant. Okay, so we're looking for any other constants in here. And I see at the end I have a minus 4. So the negative 8 and the minus 4 will go together on that problem. Okay, so now what we can do is, though, after we're able to distinguish between like terms and unlike terms, is we can go ahead and combine these together. So that's what I'm going to show you an example here for example number 1. So I underline them different colors. Some people like to shape them, put different shapes around them. It doesn't matter to me which process you use, but remember, you're looking for like terms and you're going to combine them together. So when we combine these together, though, this is called combining like terms, which is simplifying expressions, because we want to write as least amount as possible. I would say in math we like to be lazy, so we want to write the least amount. So that's what we're going to try and do here. Combine as many things as we can together by adding, subtracting, and writing less terms. So we know the 3x and the minus 2x are like terms, so we can combine those together. So we can look at the coefficients out in front of them, and we can say 3, and then I have a minus 2. So you got to ask yourself, 3 minus 2, what is that? Well, it's 1. So I can say 1x. Okay, and the variable stays the same when we add these together. When we combine them together, the variable is not going to change. You're just taking the coefficients and combining them to make one new coefficient. So 3 minus 2 gets you 1, and then the variable stays as an x. Okay, now we also could write that as just x, because we don't have to have the 1 in front of the variable if it's just if that's the coefficient. It can be, we already know it's going to be a 1 in general. So you could have just x or 1x. So then I'm going to go to my next one, because I know my 3x and my greens are done now. So I'm going to go to my purple one, my y's. So then I have 7y plus 4y. Okay, so we know the variable is going to stay the same, but we're going to look at those coefficients here. I have a positive 7 and I have a positive 4. Well, a positive 7 plus 4, or 7 plus 4, makes 11. So I'm going to have 1x plus 11y. And remember, the variable stays the same. Or, as we can write this, we can say x plus 11y. And that would be then our simplified expression for example number 1. Okay. So what I want you to do is now I want you to try number 2. So I want you to pause the video, and I want you to try and combine the terms together so you can simplify this expression down. Okay, so coming back together here, I got y squareds, that's my red. We already know those are like terms here. So I'm going to combine our like terms together by doing the operations they have. I have a positive 10 and a positive 12y squared. So 10 plus 12 is going to get me 22y squared. So now I have those done. One thing I sometimes like to do is I like to cross them off. So I'm going to put a little line through so I know I'm done with them. That's one thing some people like to do. It doesn't matter to me as long as you can distinguish. Okay? And then the next thing I'm going to do is I'm going to go to my y, my blue. And I remember this one doesn't have anything it can combine with. So I'm just going to leave it as a plus 6y. If it can't combine anything, it's just going to stay the same. Nothing's going to change with it. Okay? And then we're going to go to the green here, and we have a negative 8. You need to make sure you watch that negative sign in front of there. It's a negative 8 minus 4. So I'm at negative 8 on a number line. I'm minusing 4. So which way am I going to go on a number line? Well, we're going to go to the left. So we're going to say negative 8. We're getting further away from the 0 to the left. So that's going to be negative 12. So our answer then is going to be, after everything is combined together, 22y squared plus 6y minus 12. All right, so there we go. Let's go to example number 3 here. Now this one here, on example number 3, what I'm going to have you do is I'm going to have you find all the like terms, and then I'm going to have you combine them together so you can simplify this expression. Okay, so I have negative 3r minus 5r squared minus 7r plus 6 minus 3 plus r squared. So I want you to, like we were practicing, you find the like terms, then you combine them together by the operations of the coefficients, and then you rewrite it below. Okay, so I want you to try this all for example number 3. Okay, so coming back together, I'm going to go through, I'm going to find my like terms to start. I see I have a negative 3r, so I'm looking for everything that just has a single r. So I'm going through here and I'm seeing negative 5r squared. Nope. Hey, I got a negative 7r, so I'm going to include that with that one. Then I got a plus 6, a minus 3. Nope, those don't have any variables. Then I got r squared. Well, that's not the same thing. So I know my reds are going to go together. So my r's are together now. Now I'm going to go to my next one. I see I have a negative 5r squared, so I'm going to underline it or shape it however you want. I have an r squared, so I'm going through looking for every term that has an r squared and only an r squared. Well, I see it's just at the very end. I got a plus r squared. Okay. Then I'm going through, I'm looking at, I got a plus 6 coefficient, or not a coefficient, a constant. Oh, there's a minus 3 constant right behind it, so those can go together. So we're going to go ahead and combine these together now. I got a negative 3r minus 7r. Remember, the r is going to stay the same, but negative 3r minus 7r is negative 10r. Now going to our blue with the r squared. We know the r squared is going to stay the same, but we have negative 5r squared plus r squared. We got to remember what's the constant out in front of r squared? Well, that is a 1. So remember, you can put that 1 in there. So negative 5 plus 1 is a negative 4r squared. Okay? And then I have my constants left here. Positive 6 minus 3. So 6 minus 3 is a positive 3. So there's our expression. Now, one thing we should do is, though, is we should order these by degree. If they're all the same variable, we should order these by degree from the one with the highest degree all the way down. So one thing we can do to help clean this up then at the end is to put the highest degree, which is our r squared, first. So negative 4r squared. And then put our next highest degree, which is negative 10r. And then I have a plus 3 at the end. So that's one way you can help clean up that expression on the back end. They're still equivalent. They're still equal to each other, but it's a little bit cleaner when we do that. All right, so let's do one more here. I got example number 4. Okay, so we're going to do this one more time. I got 5y squared plus x squared minus 5y plus 7y minus 5y squared. Getting a little bit bigger now. Plus 6x squared minus 7. So I want you to pause the video and try this one. Okay, so now I'm going to quickly go through this. I'm looking through, I see a y squared. I'm underlining everything with just y squareds with red. My x squareds I'm going to underline with blue and only my x squareds. Nothing else is with them. Then I have my y's. I'm going to underline just the single y's, nothing else. And then I have my constant. I'm going to look and I see I have a constant. I have no other constants. So I'm going to combine these together. 5y squared minus 5y squared. Hey, that's 0. Those are now gone. So my y squareds are eliminated. There's 0y squared. We don't have to write that anymore. Then I have a plus 1x squared and then a plus 6x squared. That makes 7x squared. And then I have, in my green, my y's, I have negative 5y plus 7y. That makes plus 2y. And then at the, so those are all done. My blue, my x squareds are done. My y's are done, and then I have my constant at the end that I can't forget about because it's all by itself. There's nothing else. So it's a minus 7. And there's our expression. And you do notice here the degree is already taken care of here. X squared is the highest degree, comes first, then the y, then the minus 7, where the degrees descend. Okay? If you have any questions, make sure you let me know, and we'll go over this more in class.